Hi, my name is Justine Harkness, and in this video, we'll learn how to rank carbocation stability. Carbocations are carbons that have a full positive charge, and because of that positive charge, carbocations are very reactive. Now, carbocations being reactive means that they're relatively unstable. That's what makes them reactive. But they can be stabilized by having alkyl or carbon-containing substituents. So let's take a look at an example carbocation. This carbocation, we know it's a carbocation because of that positive charge. And this particular carbocation has 3 R groups. These R groups will donate electron density to that carbon, and it will make it more stable. Now, this is not to say carbocations are stable. Remember, they are very reactive. But because of all of these alkyl groups donating electron density, this carbocation would be stable enough to form in solution. The general trend that we see for carbocations is essentially the more substituted the carbocation, the more readily it will form in solution. And we're going to explore this trend more with an example. So let's go ahead and dig in. So here we need to rank the following carbocations in the order of increasing stability, and then to determine which of these carbocations would be expected to form. So the first thing we want to do is determine what type of carbocation we have, whether it be primary, secondary, methyl. So let's start with our carbocation on the far left. This central carbon with the positive charge is attached to 3 carbons. So this would be a tertiary carbocation. Going 1 over, our carbon with our positive charge is only attached to 1 carbon. So this would be a primary carbocation. Going 1 more over to the right, our carbon with a positive charge is attached to 2 carbons. So this is secondary. And the guy on the far right is only attached to hydrogens. So this would be methyl. So let's think about the trend that we have for carbocation stability. We'll start by looking at a methyl carbocation. This does not have any alkyl groups that can donate electron density. So methyl carbocations will be really unstable. With primary carbocations, we have 1 R group that can donate electron density, but that's not really enough to make our carbocation happy. It's still fairly unhappy overall. However, once we get to 2 R groups, we're able to donate enough electron density to make this secondary carbocation fairly happy. And by the time we get to tertiary, where we have not 1, not 2, but 3 R groups, we can donate a lot of electron density, and this would be the most stable of the carbocations. So the general trend that we see as we go from methyl to primary to secondary to tertiary, we get more and more stable, with the methyl carbocation being the most unstable and the tertiary carbocation being the most stable. Now we also need to determine which of these carbocations would be expected to form, and that decision can be made along this line. So methyl and primary carbocations will not form in solution, whereas secondary and tertiary have enough R groups to donate electron density to stabilize, and these will form in solution. So now you should feel more comfortable ranking carbocation stability and determining what types of carbocations will form in solution.